We have just studied that planets are moving around Sun in an elliptical orbit, right? Planets are moving around Sun in an elliptical orbit like this, but quite often we are seeing that the length of same major axis and length of same minor axis in case of motion of planet around Sun. This is semi-major axis. And this is semi-minor axis. This is origin. But this length of A and length of B do not differ by a large value. The maximum difference that we have seen in case of solar system is 3%. Right? So it's not very different. A and B are comparable. We can treat them almost equal to each other. And hence more or less we can treat the motion of planet around Sun is in a circular orbit, right? So let's assume that planets are moving in a circular orbit. This assumption is valid because A and B, the length of same major and same minor axis, they do not differ by a large value, right? So we can assume planets are moving in a circular orbit, or we can take an example of a moon moving around Earth in a circular orbit. So moon is a kind of satellite, right, in a circle around Earth. So moon is a kind of satellite. So moon is a natural satellite. We can have some artificial satellite also that we launch day to day, right? InSat satellite like. So if I regard motion of satellite around a planet or motion of Earth around Sun in a circular orbit, if I take it as circular orbit, in that case we can get some idea regarding some characteristic feature of the motion, like say velocity of the planet around Sun, or we can get the idea of energy also. Suppose R is the radius. Suppose R is the radius. R is the radius of orbit. Let R be the radius of orbit of planet, and here is Sun, and say planet has got mass m around planet around Sun. See, the mass of Sun is very large compared to mass of Earth. Mass of Sun is very large compared to mass of Earth. So since mass of Sun is extremely large compared to mass of the planet, so Sun can be taken to be at rest. We can take Sun to be at rest, and Earth is moving in a circular orbit. So in a way it is accelerating with acceleration of v square bar in radially inward direction. That's called centripetal acceleration. And what is the force acting on this planet? Force acting on this planet is gmm by r square, and under the action of this force the planet accelerates with v square bar. So from here you get the idea of the velocity of the planet around Sun. So the velocity comes out to be how much? This velocity is, this m will cancel out, so say gm by r, where r is the radius of orbit. So that's the planet velocity. That is called orbital velocity. So orbital velocity of a planet around Sun or satellite around planet is going to be gm by r. So if it is planet around Sun, m is the mass of Sun, r is the radius of the orbit, and if it is moon moving around Earth, then m will be the mass of Earth and r will be the radius of orbit in which moon is moving. So this is the orbital velocity. This is the orbital velocity. We can get the idea about the energy also. You can get the idea of energy also. The energy will be how much? The energy consists of two parts. One is potential energy and the other is kinetic energy. So potential energy is this and kinetic energy is minus That's the potential energy. And kinetic energy, for that we have to put this value of V. So that is Gm by R. And that comes to be Gmm by 2R. So that's the energy of planet around Sun. That's the energy of planet around Sun, or energy of Moon around Earth. If it is Moon around Earth, if in case of say Earth around Sun, this your M will be ms, mass of Sun, mass of Earth, upon 2R. Whereas in case of say if it is motion of Moon around Earth, motion of in case of motion of Moon around Earth, it would be E equals to minus, in this M will stand for mass of Earth, small m will stand for mass of Moon, mm, upon 2R. R is the radius of Moon around, radius of orbital motion of Moon around Earth. This is, so this is energy. In general, this is the energy, and this is the orbital velocity. You must remember this thing. This is orbital velocity, this is the energy part. Alright? And we can find the time period also. Time period would be what? Time period of revolution would be, we got the velocity and we have the circumference also. So 2 pi r is the length of orbit. We need time period upon velocity. So that will come as 2 pi r Gm upon r. So this is 2 pi r to the power 3 by 2. Or t square comes to be r cube, or t square equals to r cube. That's something which is Kepler's third law. That is something which is Kepler's third law. We have one more concept, and that is concept of escape velocity. What is escape velocity? I'll tell you what is escape velocity. See, before I tell you what is escape velocity, I want to tell you regarding boundedness of a system. When we call certain system of particle to be bounded, if you are given a system of particle, it can be Sun and Earth or Earth and Moon. When do you call the system to be bounded? See, a system is said to be bounded. The system of particle is said to be a system of particles if the system of particles is said to be bounded if the distance between any two particles never becomes infinite, right? Never becomes infinity. If distance between two particles never becomes infinity, then it is called bounded system. For example, most of the system which you come across in your real life is bounded. Sun and Earth, the distance between Sun and Earth will never go infinite. Earth and Moon, hydrogen atom, they are all bounded system. What is the example of unbounded system? When the distance between two particles goes to infinity, it is called unbounded system. The good example is Rutherford scattering. Rutherford scattering, that is the classic example of unbounded system. You have gold-filled nucleus and alpha particle. It comes from infinity and goes to infinity. the distance between alpha particle and gold fire nucleus was infinity, and finally it goes to infinity. So the system consisting of gold fire nucleus and alpha particle is unbounded system. It's unbounded system. Motion of comet around planet and comet comes from infinity and it goes to infinity. That's unbounded system. That's unbounded system, right? So that's a definition. Now coming to physics, under what physical condition you say the system is bounded? See, a system of particles, or under what physical conditions we are into? Physical condition for boundedness. Physical condition for boundedness. What is physical condition for boundedness? See, first thing I'll tell you regarding necessary condition. What is necessary condition of boundedness? The necessary condition of boundedness is the P of system must be negative. See, sign of potential energy gives you an idea of nature of interaction in the system. If the P of the system is negative, then that means the nature of interaction within the system is attractive. If P of system is positive, then that means the nature of interaction is repulsive, right? And so let me write it. If P is negative, that implies the nature of interaction is attractive. If it is positive, that implies the nature of interaction in the system is repulsive. And this statement is based on the assumption that interaction within system between two particles has inverse variation with distance. I am saying this based on the assumption that interaction within the system between two particles has got inverse variation with distance, and that assumption is quite valid if the interaction taking place in the system are basic interaction. Basic interaction means, so you have four basic interaction in universe, that is gravitational interaction, Coulombic interaction, strong force and weak forces. Strong force means the force which you have in nucleus, that is strong force, right? So all these interaction always have got inverse variation with distance. All these interaction always have inverse variation with distance. You see, in case of spring force, interaction does not have inverse variation with distance. You see, F is minus kx. If this block is far, force is stronger. So here interaction, which is denoted by force, does not have inverse variation with distance. But then the spring force is not a basic force. It's the outcome of electromagnetic interaction that is taking place inside the spring, right? So spring force is not a basic interaction, it's outcome of the electromagnetic interaction that takes place inside spring, right? So for basic interaction this is valid. Basic interaction this is valid, and then that follows it follows from this assumption only. I can prove it also. If P is negative, the force of interaction inside the system is attractive. I can prove if the interaction is attractive, P has to be negative. See how I define P? I define P as, see, if a sun and earth, see, interaction is a gravitational system. In gravitational system it is always attractive. So for gravitational system this necessary condition is always satisfied. For gravitational system this necessary condition is always satisfied. First of all, let me prove this one by one. So I want to show you that if the interaction is attractive, P has to be negative. Why? See, if interaction is attractive, how do I define P? P is defined as work done in bringing this earth from infinity to this position quasi-statically. So when I bring earth from infinity to this position, when I am here, this earth is getting attracted towards sun, and in order to keep it in equilibrium, I need to apply external force in this direction, and the motion is taking place in this direction. See, in order to keep earth in equilibrium, see, because see the definition is the work done in bringing a particle from infinity to a given position such that that particle never accelerated. But while I bring this earth from infinity, this earth is experiencing a gravitational force towards sun, right? So in order to keep it in equilibrium, the external agency must apply FEXT in direction opposite to the gravitational force exerted by sun on the earth, and displacement of earth is in this direction. So force you are applying and displacement is opposite. Done by external agency is negative, and hence P is negative. Hence P is negative. Whereas if interaction is repulsive, suppose we have gold foil nucleus and we have alpha particle, and we want to find potential energy, then again same definition. The work done in bringing this alpha particle from infinity to this position such that alpha particle never accelerated. So if this is alpha particle, while I bring this alpha particle, gold foil nucleus repel it, and in order to keep it in equilibrium, the external force has to be in this direction, and displacement is also in the same direction. So force and displacement, they have same direction, so work done by external agency is positive, and hence P is positive. Hence potential energy is positive. So when the interaction is repulsive, P is positive. When the interaction is attractive, P is negative. But this is all valid under this assumption. Under this assumption. But since we are into gravitational system, all these things will be always valid. Because in case of gravitational system, your interaction is attractive, P is always negative. Interaction is always attractive, and P is always negative in that case of gravitational system. So in case of gravitational system, this necessary condition is always satisfied. What's the meaning of necessary condition? Necessary condition means if this is satisfied, then we can think of boundedness. If this is not satisfied, we cannot think of boundedness. For example, when you are preparing for IIT JEE, then passing class 12th exam is necessary condition. Passing class 12th exam is necessary condition. It's not sufficient, but it's necessary. You don't pass this exam, you can't appear. You can't think of getting into this exam, right? And if you are passing this exam, then again there are certain other conditions which has to be satisfied for getting into this college. Get your point? So this is necessary condition. Necessary condition does not mean that it will be bounded. We can think of boundedness. We can think of boundedness. All right. For example, in case of say sun and earth, the interaction is attractive, P is negative, and it is bounded also. Whereas in case of earth and comet, the interaction is still attractive. Potential energy is negative, but still it is unbounded. Earth and comet, interaction is attractive, P is negative, but still it is unbounded. Whereas earth and moon, the P is negative, potential is negative, and it is bounded. So what else has to be satisfied in order for the system to be bounded? See, now we are into sufficient condition. You understand necessary condition? If it is negative, we can think of boundedness. If it is not negative, then we cannot think of boundedness. For example, gold foil and alpha particle, the potential energy is positive, so boundedness cannot be thought of. There is no point of a system to be bounded. So what is sufficient condition? Once you satisfy the necessary condition, what else has to be satisfied? What else has to be satisfied? See, for a system to be bounded, it's not like that only P has to be negative. P has to be negative, but apart from P getting negative, there is one more thing which will play a big role in the boundedness of a system. See, a system is said to be bounded if before I go to sufficient condition, I must tell you about kinetic energy. See, in case of boundedness of a system, the negative value of P is a necessary condition. Of course, if a system is set to if you want system to be bounded, the interaction has to be attractive. if the interaction is repulsive, we can never think of boundedness. So interaction has to be attractive, and in terms of physical quantity, we just say the same thing by saying P is negative. P is negative, but that is not a sufficient condition. We have seen the example of Earth plus comet. Earth plus comet, when comet comes near the Earth, Earth attract comet. It's not like Earth is repelling comet. Earth is attracting comet with gravitational force, but still Earth and comet forms an unbounded system. So there must be something more to the condition of boundedness. That's only necessary condition. That's only necessary condition. So we are into sufficient condition. So over here, I would like to tell you about the role of kinetic energy. See, kinetic energy is something which determines the motion. Kinetic energy is something which is describing the motion in system. And I would like to tell you one thing, that kinetic energy always takes the system towards unboundedness. Kinetic energy, motion always takes the system towards unboundedness. K always takes the system towards unboundedness. So negative P is trying to make the system bounded, and K always takes the system towards unboundedness. So that means a system will be bounded if P is negative, and not only negative but in magnitude it should be more than K. P should not only be negative, but magnitude wise it should be more than K. It should be dominating over the K. P should not only be negative, but in magnitude it should be more than kinetic energy. Or in a way, I can tell the same thing by saying energy is negative. If P is negative and magnitude wise it is more than K, that means energy is negative, and that's the sufficient condition. That's the sufficient condition of boundedness. That is the sufficient condition of boundedness. You can see Earth and Sun. See here. This was your potential energy. It's negative. And this is your kinetic energy. Always positive. So P is not only negative, but magnitude wise it is twice of K. Magnitude wise it is twice of K. And hence energy is negative. And hence Sun and Earth is a bounded system. Sun and Earth is a bounded system. In case of hydrogen atom, if you remember H atom, what is your P? P is minus Me4 4n square h square epsilon naught square. And what is kinetic energy? Is Me4. So what do you find? P is not only negative, but magnitude wise it is twice of K. P is twice of K. P is not only negative, but magnitude wise it is twice of K. And total energy is Me4, which comes to be minus 13.6 n square eV. Right? So that is sufficient condition. K will always take the system towards unboundedness. K will always take you towards unboundedness. Right? So this is P and this K. So that's the sufficient condition. And once we come at this condition, I'd like to tell you, so for if energy is negative, it is bounded system. And once we discuss this thing, I'll tell you about binding energy. What's binding energy? See, binding energy is a term associated with bounded system only. If system is bounded, then natural question, how will you make the system unbounded? See, if I want to make this hydrogen atom unbounded, what should I do? See, from outside, you cannot change the potential energy. Potential energy is something which depends on the interaction between proton and electron. But from outside, you can change this kinetic energy. You can pass radiation, the photon will strike on the electron and it will increase the K, right? It will increase the K. So binding energy means what? How much energy you have to provide from outside for the system to be unbounded. If you are given a bounded system, then how much energy you must provide from outside so as to make the system unbounded. So as to make the system unbounded. So if I want to make the system unbounded, what is my option? My option is to increase the kinetic energy and increase till what value? Increase it till this K becomes equal to P in magnitude. See, your system was bounded when P was dominating over K. So if I increase K from outside such that the magnitude of K becomes equal to P, then in that case the system will be on the verge of unboundedness. Or in other words, I can say this energy is what? This energy is nothing but difference in the magnitude of P and K. So I must increase the energy of the system by this value. I must increase this energy of the system by this value, right? Because this energy is nothing but it's the difference of, it's telling you how much P is greater than K by how much value. P is greater than kinetic energy by how much value, right? So if I want to increase the, if I want to make this hydrogen atom unbounded, I must provide from outside this amount of energy. So we define it like the amount of energy which has to be given from outside in order to make the system unbounded. That's called binding energy. And for bounded system, binding energy is equal to modulus of E. For example, if I take ground state H atom, the energy is minus 13.6 eV. So binding energy will be 13.6 eV. If you give 13.6 eV, because this is what? 27.2 eV and this is 13.6 eV. So I must increase the kinetic energy by 13.6 eV in order to make the system unbounded. In order to make the system unbounded. Alright. See in okay, fine. So let me tell you some more thing. In case of, let me take an example of gravitational system. See, in case of gravitational system, suppose we have this earth. So when we are having certain object on the earth, say a body of mass m, and this is mass of earth, what do you call this system to be bounded or unbounded? If a body of mass m is lying on the earth, what's the potential energy? Potential energy is Gm by Re. And what's the kinetic energy? Kinetic is 0. So your total energy is, and hence this system is bounded. This system is bounded. The energy is negative. If I want to make it unbounded from the earth, if I want to make this unbounded, then what should I do? I must increase the kinetic energy to what value? I must increase it to such a value that in magnitude this becomes equals to P. And if kinetic energy in magnitude becomes equal to P, what should be energy? Energy will be 0. Yeah, P is negative, K is positive, and in magnitude if I increase K and K becomes equal to P, then energy will be 0. So what would be V? From here we get V as 2 Gm by Re, and that's the velocity I must provide to this body in order to make it unbounded from the earth. Making unbounded with the earth means it will go away from the earth. It will no longer be bounded to the earth, it will become unbounded to the earth, and this is called escape velocity. This is called escape velocity. Alright, so this is amount of velocity which you must provide from outside in order to make any particle go away from the earth. Right, it will overcome the gravity of the earth. And if I put the value, this is 11.2 kilometer per second. Very high velocity. It's very high velocity. Okay, so I hope in nutshell you understand how this system is bounded and unbounded, because escape velocity is something which is the climax of this topic, boundedness. Okay, so in brief I have told you what is boundedness and unboundedness. There is lot more thing in this topic, but that is beyond your syllabus, right? So I'll